In this question here, we're told that the weights of marmalade jars are normally distributed with a mean of 250 grams. So we don't seem to be told any other parameters. As I read part A, I'm asked to calculate to 2 decimal places the standard deviation of these jars if 1% of the jars are heavier than 256. So I'm going to start off with the distribution that I know so far. So the mean is 250 and we have an unknown standard deviation, so I'll just use sigma squared. I'm also going to write this probability statement, the probability that x is greater than 256 equals 0.01. Okay, on the diagram, 250, 256, and this should be 1% over here. Okay, so these are the x values. I'm going to need to compare these to a z-score, so I want to get the z values that represent these as well. We know that the z-score in the middle is going to be 0, and I can use my calculator to find the z-score for 1% above. On my calculator, I'm going to do an inverse 0.99. You can put the standard deviation and the mean of the standardized distribution, which is a standard deviation of 1 and a mean of 0, and we get the answer 2.3263. If you accidentally use the probability 0.01, I would actually get negative 2.3263. But because we have the diagram, that's our safety net. That lets us know, actually, I need the positive version of that answer. Students without a diagram who make that error, just go ahead with that negative value and get an answer that doesn't make sense. Anyway, we have a z-score and a real-world value, and we have our standardization formula that we can use to find the unknown standard deviation. So, just quoting the formula, z equals x minus mu over sigma. Substitute in everything that we know. We'll just do a little bit of rearranging here. I could simplify this. I hope you know straight away this is 6, but I'll do that on the next line. So 6 divided by 2.3263 should give me 2.5791. Okay, the question did ask for 2 decimal places, so that'll be 2.58. Part B of the question, we're asked, using our answer to part A, so using our standard deviation there, find the probability that the weight of one such marmalade jar is between 249 and 253. Okay, so this is just a standard normal distribution question. What is the probability that a marmalade jar that's chosen is in between these two weights? So I'll just write out the statement. What does this look like on a diagram? It needs to be in between, well, let's get the 250 down. It's going to be in between 249 and 253. Right, so I'll just shade that in quickly. Okay, and back to the calculator. We can do a little NCD. Lower limit 249. Maximum value 253. Put in a standard deviation. I'll put in my fuller value here. And the mean of 250. Okay, and that gives us an answer of 0.5285. Okay, and part C. Got to be really careful here. Part C says given, so it's a conditional probability question. Given that the weight of a marmalade jar is in between 249 and 253, determine the probability that the jar weighs more than 250 grams. So the very first thing I'm going to do is I'm going to write this out in the given notation. So I'm looking for the probability that it weighs more than 250, given that it's in between these two values. Okay, looking at my diagram, that means I'm initially interested in just the yellow highlighted part, and then more specifically from those, what is the probability that it's larger than 250? What is the probability it's this shaded region? Okay, so we need the intersection of the two, which is the shaded region, over the probability of the second one, which we found in the early. Okay, so I'm just going to write that out. The intersection of the two of these, so my shaded part is 250 to 253. So I'm going to have that over the entire highlighted part. Okay, and individually those answers are 0.3176, and we found the previous one in the question, 0.5285, leading to an answer of 0.7145.